Hello guys, I'm Dima from Computage. This short lecture will briefly guide you in our aging theories challenge. I will explain you why do we need a theory of aging and how to create a good one. Let's start with some historical remarks. On this slide, you can see how human life expectancy changed across different periods in the past. Before the invention of vaccines, people on average barely lived to 50 years. However, after the introduction of mass vaccination in the middle of 19th century and later after the discovery of antibiotics in early 20th century, average life expectancy began to rise steadily. And now we've hit a new threshold. You can see how in modern times this curve is saturating. Our new challenge is aging, which we still cannot overcome. What's worse, we cannot even fully understand it. Why is it important to understand aging? Why is it important to have a theory of aging? Let me quickly show you how even a naive but correct theory can be extremely effective. Take immunity. How does it work? It all starts when the body detects an infection. This is done by special immune cells in our body that patrol in real time. Once they detect the infection, then they raise an alarm and call in reinforcements. The arriving cells attack the pathogen using different units against different threats. If they manage to overcome danger, they remember it so that the next time the pathogen appears, the infection can be dealt with much faster. That's how the immune system trains itself. Now, even from this oversimplified scheme of immunity, you can guess the idea. What if we take a weaker copy of the pathogen and train the immune system to fight it? The result is a vaccine. But more importantly, this allows us to increase human life expectancy by 30 years. Can we repeat this success with aging? So maybe, if only we had a theory. What is the current status of aging theories in science? First, we have the hallmarks of aging, a big list of phenomena observed in aging, such as genomic instability, telomere shortening, mitochondrial dysfunction, and so on. This is a great framework to think about different aspects of aging, but it is not a theory. It doesn't tell us what causes aging, how the different hallmarks are connected, and most importantly, it doesn't suggest any therapy to slow down or reverse aging. A good theory, in contrast, should predict a drug or therapy against aging that we could test in experiments and then, depending on the results, refine the theory. Searching for an anti-aging drug without a theory looks to me like searching for a needle in an ocean of haystacks. But with a good theory, we could narrow the search to just one haystack, which is still difficult, but at least feasible. Many aging theories have been proposed. Here's a very short list, including some that were suggested almost 100 years ago. They explain aging with varying success at different levels of biological organization, cellular or molecular. Some of them don't even provide mechanistic explanations, but just reduce aging to entropy growth or loss of resilience. Let's consider one of the early theories, the energy consumption hypothesis, which states that organisms possess a finite reserve of some vital substance, which gets depleted over time. Sounds good, but what is this vital substance? Can we measure it? Can we cure aging by replenishing it? This theory gives no answer. On the other hand, there's the DNA damage theory. DNA damage, including mutations, accumulates with age and drives aging phenotypes. This is more advanced than mechanistic theory. It proposes specific molecular change in DNA as the main driver of aging. Accordingly, it points toward therapeutic strategies, such as enhancing DNA repair mechanisms. Unfortunately, even this theory can't explain everything. For example, it purely explains why calorie restriction extends lifespan in many animals. We can also look at the state of aging science from another angle. Here's the top 10 drugs from the Drug Age database tested in mice. The best one extended lifespan by only about 20%. Not bad, but not a twofold increase. So, a great idea would be to build a theory that explains this result and tells us how to improve it. Another recent example shows that a combination of two drugs, rapamycin and trametinib, extends mouse lifespan by 30%. Again, a great idea here. You see where I'm going. Build a theory to explain and improve this result. So, let's get to the main point. what makes a good theory of aging. I believe a good theory of aging must satisfy the following 4 criteria. And listen carefully, please, because part of the competition will be based on them. I call such a theory a constructive theory of aging. The 4 criteria are: first, the theory must suggest biomarkers that explain maximum lifespan across different species. Second, the theory must suggest biomarkers that explain mortality within a species. Third, it must predict a testable longevity intervention. And of course, it must be mechanistic, not phenomenological. That means explaining aging in terms of molecular pathways and biochemistry, not abstract terms like vital capacity, entropy, or loss of resilience. Now let's talk about your challenge. In this challenge, you will collect and classify theories of aging. You will be given 2 tasks, which are better done in sequence. We will evaluate your performance to determine the winners, who will receive not only monetary prizes, but also co-authorship in a scientific paper that we will write based on the hackathon results. In the first task, you will need to collect scientific papers relevant to aging theories. The main difficulty here is that not all papers focus on a single theory. Some cover multiple theories, some may be not about biological aging at all. How to correctly distinguish the relevant ones, that's a job for your agent. As output, you will provide tables in a specific format. More details about the format of tables are in our Discord. In the second task, your goal will be to answer some very important questions from our prepared list. We have also prepared a validation dataset of 10 well-known papers on aging theories, where we have already answered these questions. We'll compare your answer against ours. It's important to clarify, we always ask questions about a specific paper, but since multiple papers may refer to the same theory, it is important to merge answers. For example, answers to questions 1-4 might be in one paper, while the answers to question 5 might be in another paper. As I said, we will evaluate your results based on the submitted tables and calculate specific metrics. In the first task, the more relevant papers you find, the better. In the second task, correctness of answers is a key. The final score will be based on the average rank of metrics from both tasks. So, that's it, guys. I wish you good luck in Aging Hack, and thank you for choosing the Computage challenge on aging theories.